In this video, we're going to discuss how to factor sum and difference of cubes. So here we have a binomial with nothing in common, so we can skip GCF. It is a binomial, and it is a sum of perfect cubes. So you could follow this formula, or I will also explain to you with a second example where this formula actually comes from using factor theorem, which is part of grade 12. Before I proceed, I would like to notice that these formulas are almost identical to each other, apart from the signs. So I'm going to use a mnemonic device, SOAP, to help you remember this. So what does SOAP stand for? S stands for same sign, O stands for opposite sign, and then AP is for always positive. So if you noticed here is that if the original question was positive, then the first sign here in the binomial is a plus sign. But then in the trinomial, it follows by a flip. It becomes a negative, and then it's positive. And in this question here, we have a negative. So first sign in the binomial is a negative, and then in the trinomial, it switches to plus, and then at the end, it's positive for both of them. And so just remember SOAP mnemonic device to help you do this. Another note I want to mention is that these two trinomials, if you were to try to factor them, there is no way for you to get this middle term. Let me explain. So a squared is a times a, and b squared is b times b, or possibly negative b with negative b. So if you try to do crisscross here, we'll have a times b, which is ab, and another ab. So it's one AB plus a second AB should be two ABs, but we don't have a 2 here. And if you try to do it with negatives, you'll have negative AB and another negative AB, which is supposed to be negative 2AB, which is not up here. So the trinomial that you get from these will never factor, so you don't have to bother trying. Just make sure that you check that GCF is pulled out if there was any. So let's do this question. I'm going to use a method 1, which is using a formula. And before you use the formula, we need to identify what is being cubed for each of these terms. So in the first one is 3 times 3 times 3 is 27, and x times x times x is x3, or x cubed. And the second term is 5 times 5 times 5, which gives you 125. And so our little a is 3x, and little b is 5. So then following the pattern, we'll have a binomial and then a trinomial. I don't have the signs filled in. We're going to use SOAP to help us. So this original question had a plus sign, so same sign, opposite sign, always positive. And then we just fill it in. A's and B's filled in, so we have just A, just B. This is a squared, so 3x times 3x is 9x squared. Then AB, so that's 3x and 5 multiplied together, 15x. And then 5 times 5 for b squared is 25. So as I said, you do not have to try to factor this one. I mean, you could try, but it will never work. And there is no GCF between all of these terms, so you could stop here. Method 2 is using factor theorem and long division. I will show that in the next example. Here's my second example. So first of all, we should do a common factor because there's x in both terms, and whenever you encounter a fraction, it is best to pull out that fraction as well to make things simpler inside the brackets. So for us to pull out a fraction, we want to rewrite it as a common denominator. So this negative 12, we need to think what's really up here so that when you divide by 2, you still get negative 12. Well, it's at 24. And so now we're looking at what's common between those two terms. So x is common, 3 and 24 on top, there's a common of 3. And both of them have a denominator of 2, so we can pull out a 3x over 2. What's left over is going to be x to the 3 minus 8. Then this inner bracket now is a binomial, and it is a difference of 2 cubes. So we can proceed. I'll do it on the next page by using the formula again. So here's where we left off. So you have to identify what is being cubed. Here x is being cubed, and for the 8, it's 2 cubed gives you 8. Then here's the formula that we usually have, a binomial and then a trinomial. And then in terms of signs, if our original question had a minus, we need a minus to start, then opposite of that, and then always positive. And then we just fill things in. Please don't forget this GCF that we pulled out. That's still part of the question. Then we have x minus 2 as a minus b. Then a squared would be x squared. AB will be 2x. And then b squared will be 2 squared, which is 4. And then again, you don't have to try to factor this. It will not, as long as there's no GCF within it. Method number 2. For this method actually is for grade 12s. So if you're in my enrichment program, I'd like you to just follow the formula. If this goes too fast for you, not a big deal. You're going to see this in grade 12. If you're listening to this from grade 12, then this is something that you need to learn or understand where it comes from. So factor theorem. The factor theorem states that a polynomial f at x has a factor x minus k if and only if you put the k value into the polynomial, we would get a 0. In other words, k is the root. So for our purposes, let's just take this binomial here. That's a perfect cube, difference of cubes here. And let's say that this represents the function. We want to find a value that we plug in and get a 0. So what cubed minus 8 gives you a 0? Well, 2 plugged in gives us a 0. So by this theorem, x minus 2 should be a factor by this factor theorem. Once you find a factor, all you have to do is take this factor and divide it into this original function to see how it breaks down. And we'll need more space, so let's go over here and rewrite. For long division, we need some placeholders. So we'll have x cubed and then x squared term, then an x term, and then the constant term. So because we don't have these, we place zeros here. So for the division, you concentrate on the first term of each one. So this is the divisor, and this is the dividend. So we're going to concentrate, if we take this x cubed and divide it by x, what do we get? We'll place that as a quotient up top. Well, it's going to be x squared. But next step is now to take care of the 2 terms of the divisor, not just the first one. So we're going to multiply x squared with x and x squared with negative 2 and place that underneath. So this is what we get. Then what we want to do is subtract the alignment of these terms. So these are like terms. This is the reason why we needed to place a 0 here as a placeholder. X cubed minus x cubed will be 0. 0 subtract a negative, so that's like double negative here, so positive 2x squared. And we need to carry down the next, so to speak, digit or a term, because our divisor has 2 terms, so we have to have the 2 terms here to work with. Then we repeat. We concentrate on the first term of each one and do the division. So 2x squared divided by x, and record it above here in our quotient, which is plus 2x. Then we take this plus 2x only, not both of these, just this term here, and multiply with the divisor, both with the x and negative 2. So 2x times x and 2x times negative 2, and place it underneath these 2 terms. Then we subtract. Once we subtract, we carry down the last number. And then we concentrate on the first 2 terms again. 4x divided by 4x divided by x is 4. Multiply this 4 back with the divisor, so we'll have 4x minus 8. And when you subtract, you get 0. If you do not get 0, then this factor that you said originally is a factor. You were wrong. So you'd have to try to find another number that actually does work, or check your calculations inside here. So what does the long division tell you? Long division could be written this way. So this cubic is divided by this linear factor. And when we divide it, we got evenly this quotient, from here. Now, that's not a polynomial because polynomials shouldn't have any divisions. So if we multiply both sides by this factor x minus 2, we would have this result. So this is equal to that factor and then this trinomial. Well, this should look familiar. We've seen that in the formula from before. So all we have to do is just place our final answer, not forgetting our GCF to start with, and then the two factors we got from factor theorem. So final note, the flowchart could be adjusted by saying that after you try common factoring, you could try factoring using factor theorem. That works for any polynomials. Just keep in mind that that method only can find rational roots. The irrational roots are not possible to do so. With that method, you would have to use technology, or after you learn calculus, there's other ways to approximate those solutions using calculus methods.